philosophy of it, I guess. All right, so this is my algebra tiles. This bar represents my equal sign. So here I've got two separate equations. I'm saying that x is equal to 3, and I'm saying that y is equal to 5. Nothing different about that, nothing difficult. Are we all good with that? Okay, separate them. If I do what we've talked about before, let's say I copy that and I have 2x's is equal to 6. Are you happy with that? X maintains the same value if I double both sides. Okay. There are other things I can do. So for instance, if I were to put another x add 1 here, what would I need to do on this side? Add 1. But because I have 2 of them now, I would actually have to do that to both of them, right? So I have to do the same to both sides. But basically, if I multiply both sides by 2, I keep that same value of x. I'm not changing the value of x, all right? So that's kind of the philosophy that we've done before when solving equations. So let's just have a look at this. What if I then combine these two things? So I now know x is 3 and y is 5. But what if I were to put them in the same equation, right? So I've got x and y, and then I've got 8 there. Is that 8? Is it? Yeah. Okay. All right. If you didn't know that x was 3 and y was 5, is there any way of knowing what x and y could be? No. All right. Because I could split it anyway. Now, let's assume I'm sticking to integers. I could have y is 1 and x is 7. I could have y is 2, and you get the idea. I could split this up. And if I then consider the fact that actually algebra tiles is limited by the fact that we can only do integers, but you guys know that integers are only a small set of the total number of numbers we have. We could have decimals or anything. So there could be an infinite number of things. All right. So how could we find what x and y would be? Well, we can find x and y by having a second piece of information. All right. For instance, the easiest piece of information I could give you is x is equal to 3, right? If I gave you that, how could you then determine what y was? Yeah, so if I know that, if these are the two separate equations like we've been talking about before, if I know that these two equal that, and then I know that this x is the same value as that x and equals 3, well, I can then break this up and I can separate it and say, well, I know that, so therefore, using this extra clue, I can then say that y must be the 5. Okay? Make sense? So we're really looking for the difference between two equations to give me a clue as to what's going on. All right? So what happens, for instance, if I include another y? Okay. Well, we know that I'm going to have another 5. 5. One too many. Okay. And if I have this information as my second equation, 2, 3, 4, 5. Right, so now I've got two equations where 2 y's and an x make 1 y is equal to all of this, and 1 y and an x is equal to this. Could we use that to solve the equation? Do I have enough information? Yeah, same thing again, isn't it? Because I would know, actually, instead of separating the x and the y, I know all of those together, so therefore I can separate that out and I'm left with what y must be. Okay, so this is kind of the philosophy that we're doing with when we're doing an elimination method. We're trying to determine what must have been the difference between the two equations. All right, what must have made the change? So for instance, another way to think about it, if I separate that y, okay, so at the moment my two equations are exactly the same, right? Y plus x is equal to 8, y plus x is equal to 8. But if I add an extra y in and I add an extra 5, I can look at the difference between those two and say, all right, well, the difference on this side is a y, and the difference on this side is 5. Therefore, the y must be the 5. It has to be. Okay, so that's the philosophy that we're looking at. We're kind of trying to find the difference. Does that make sense? Any questions on that at the moment? No? Okay, right, let's get on to doing that algebraically then. So let's have a look what it looks like. So if I give you the two equations, so let's say we've got our, I'm going to do x's and y's differently. So 2x plus y is equal to 8. Okay. All right. And then I say that 1x plus y, okay, give me something that it could equal to. So can anyone pick a value of x and y in their head that would work for 8 and then tell me what x and y must equal? But don't tell us what it is. Yeah, let's try and have integers. Just tell me what this answer would be and we'll figure it out. No, don't tell me what x is equal to. Tell me what x plus y is equal to. 5. Okay. Yeah? There's going to be a limited ones to keep it simple. All right. So here's my first equation. Here's my second equation. Now, what we do is we find the difference between those two. We try and figure out what made the change. What's the mathematics behind finding the difference between two equations? What's the mathematics? Subtracting. There you go. So I'm going to do, well, I'm going to do equation number 1 subtract equation number 2. So what I end up with is the 2x's subtract the x leaves me with an x, and 8 subtract 5 leaves me with 3. What does the y subtract y give me? 0. Okay, so can you see where this elimination method thing comes in? Right. Where do you think the elimination method comes in, guys? What does to eliminate mean? Yeah, by subtracting, look, we managed to eliminate the y. And remember what I said before, what we need to do is we've kind of figured out that, well, y doesn't have any impact on the change in the answer. Okay, I've got nothing happened with the y. So if I subtract these, I eliminate this y and I'm left with how many x's it would be. All right. So that's where this elimination method, so I now know that x has to equal 3. This is a very simple case, but it's obvious, right? Does that make sense? What would I do then to find y? Exactly. You do exactly the same thing that we did in substitution method. So the second half to find the other variable is exactly the same for both methods. So I might use x equals 3 in x plus y is equal to 5. So I've got 3 plus y is 5. Therefore, y is equal to 2. So is that what you picked? Did you pick 3 and 2 for x and y? Yeah. Okay. So we can solve that. So that's kind of our elimination method approach. Any questions on that at the moment? No? Okay. All right. Well, let's have a look at one that's in the book. All right. Because we're going to step it up a level. The book goes straight to quite challenging ones. But let's have a look. So we've got 2x's, but we subtract 5y's, and I get the answer 9. That's my first equation. Now, remembering what systems of equations about, I'm using the same value of x and y. So 2x's subtract 5y makes 9, but using the same x, if I take 3 of it, but then add 2y's, I get the answer 4. So I'm obviously going to get a different answer by doing different things. First off, why would substitution method be quite challenging for this one? Cameron? No? Gave up quite quickly? Think about the methods that you were using. Why do you think? What could potentially be a problem for you? We did mention it the other day. No? Jasmine, what do you think? No? There's nothing in there that would make the work that you did yesterday more challenging? Anaya, what about you? Well, negatives is potentially not a problem, but I get you. I get what you're saying. But there is kind of one problem that we looked at. Do you remember at the end, guys, I gave you a one that would be harder. It was in the examples, and they said this is the reason it's going to be harder to do. We could do substitution. What was it? Aidan, is that you? Good. That was it, wasn't it? Well done. So there's no single y or x that I could rearrange and isolate. I've got more than one x in both, and I've got more than one y in both. Okay. Now, even though we've still got a bit of an issue to work on, because what's the problem with this question compared to what I've been talking about, like with this one, for instance? We were able to eliminate the y's. How could I eliminate the y's? Why was it possible to eliminate the y? Anyone? Yeah, exactly. Because I've got one y and one y, I know the x must have made the change, yeah? And by subtracting, I get rid of the y's. I eliminate them because it's the same number. So I find the difference between the two equations. That leaves me with what must have made the change. So the change was 1x was added and the answer went up by 3. However, if we look at this slightly harder one, what do we notice? Well, this is 2x's subtract 5y's gives me 9, but this one's 3x's plus 2y's gives me 4. So I've changed everything, all right? Both x's and y's. So we're kind of now looking at it going, well, I can't do it, all right? But I did something at the very beginning with my algebra tiles to show you something. And I did it as a multiplication. So for instance, if I take my first equation, all right, just like you've done in the past, if I take number 1 and I multiply number 1 by 3, what do I end up with? Yeah. So you remember when you multiply everything, not just one bit or not one half. Are you good with that, Jelena? Does that make sense to multiply by 3? Yeah? Okay. Satya, so I've given you a clue then. I'm going to do the same thing to number 2. Well, similar, but what would I multiply by? Multiply by 5. I could, but I wouldn't. That wouldn't help me. Not by 5. No? Anyone else? Yeah, if I multiplied the second one by 2, I get 6x in both equations. Okay, but this one will be 6x plus 4y's is equal to 8. Okay, now that process, I'm not linking the 2 yet. I'm just saying that, well, if 2x's and subtract 5y's is 9, then it is also true that 6x's subtract 15y is equal to 27. It's actually a new equation, but it's still true. And the same with my number 2, right? It's still true using the same x's and y's. So I'm developing my own logical statements. So this is our ATL or IB Learner profile thing about being logical, making statements that must be true based on the information that I've already been given. All right. So as long as I'm happy with that, that's good. Now, the reason why I've done that is I think you can all see now is it has given me what? 6x's on both sides. So now I know that the x in this situation, using the same x's and y's as this lot, all right, so it doesn't change the x's and y's, so that's all I want. I know that the x's have not affected the answer, okay? So there's no effect because they're the same. So therefore, whatever I did to the y has to have impacted the answer. So this is the important bit. So y is change. All right. So what is the change? What do we actually do? So it depends which way you want to work. So anyone want to tell me what the difference between the two things has happened?
Why?
So you're going to work from number 2 up to number 1, yeah? So if I start at 4y and I subtract 11y, is that right? You sure?
Why?
No. I've got negative 15y and positive 4y. So if I've got 4y's and I end up with negative 15y's, how do I get there? I must have subtracted, is it not 19y's? Yeah? Yeah? Is everyone seeing that? The negatives again causes problems. If I go from 2 to equation 1, I could have done the other way. So for instance, if I'm in the same situation, all right, hopefully I don't confuse you. I've kind of eliminated x as an issue. I don't need to consider it. I could go the other way and say, how do I get from negative 15 to positive 4? I have to add 19y, but this time the answer has gone down. Well, this one, the answer goes up. So this, if I do negative 19y's, the answer goes up. So I'm actually going to add how much to the answer? 19. But if I do it this way, instead the opposite way, I've added 19 to y. but this time I have subtracted 19 from the answer. And are we going to end up with the same thing? Yeah. So if negative 19 lots of y makes positive 19, what must y be? Negative 1. Yeah? Okay. So we've got a couple of steps there. First off, we must multiply to get one variable to have no effect. Okay, so that's what we've did, and then we work out what the change must have been. All right, so we're going to formalize this a bit with, we get to a stage where we say, oh, you always add them or always subtract them, or at the moment we're just going to talk about identifying what the change must have been. I think is a better way of considering it. How does everyone feel about that at the moment? Okay, that's one good. Anyone else good? Yeah, a little confused. Good. Okay, I like a confusion because you're being honest. Right, should we have a look at another one? All right, let's have a look at another one. So let's do, we've got 5x subtract 3y's is equal to 5. Okay, that's my first equation. And my second equation is 3x's plus 2y's is equal to 4. Okay, now we multiplied to make the x's the same before, but we don't have to. We could do the y's instead, whatever you want to do. So let's focus this time on eliminating the y instead. So have we got the same number of y's? No. So, and we've not got the same number of x's, so both of them are having an impact on this answer at the moment, so that's not helpful. So what we need to do is consider how one of them is going to impact. So what I want to do is make the same number of y's in both by finding equivalent equations. And to find equivalent, if I write, we're going to find the LCM of the y coefficient. Does that make sense?
Yeah.
What's an LCM? Lowest common multiple. So what's the lowest common multiple of 3 and 2? 6. So I'm going to have 6 y's, and I've just got to figure out how to get there. So what do I do to get 6 y's? Multiply by 2. And this one I have to multiply by 3. So if I do that, I have to do the same to every single part. All right. So what I end up with, my new number 1, well, that's going to be 2 lots of this one. So that's going to be 10x's, and it's going to be negative 6y's is equal to 10. And I did 3 lots of number 2. So that's going to give me 9x's plus 6y's is equal to 12. Okay. We've still got a problem, haven't we? What's the problem? Exactly. So is negative 6 the same thing as positive 6? No. So there are 2 ways to solve this. Anyone want to come up with one way that they think could work? We've got 10 minutes left. What could we do?
Times equation 1 by negative 1.
Yeah, or even back to the start, we could multiply it by negative 2 instead, yeah? Did everyone get that? So instead of multiplying by positive 2, let's multiply by negative 2. And what would that do for me? So we'd end up with, instead of 10x, we'd end up with negative 10x. Instead of negative 6y, we'd end up with positive 6y. And instead of 10, we'd end up with negative 10. are we in a good place now? Yeah, because now, which one can I isolate? Which one can I get rid of and eliminate?
Y.
Yeah, so the y's are the same, so they have no impact on my answer. So my answer changing is merely what happened to my x. So what's the difference in the x then? You've got to decide which way round you want to work. So which way round do we want to work? What did we do to the x? We either went from 9x to negative 10x, or we went from negative 10x to 9. Which way do you want to go? What do you want to do, guys? Pick one. Not a trick question. It's not a hard question. You decide.
Up.
Up. Okay. So we're going to go up. So from 9x, what do we do to get... So we went from equation 2 to equation 1. What do we do to get from 9x to negative 10x?
No. Subtract 19.
We subtract 19, don't we? Subtract 19 x's. Okay. And again, we have... This is why I label it so much, guys, because obviously I have to do it the right way. Because if I did that way, and then did the answer, it'd be having an opposite impact. So I want to know then, by subtracting 19 x's, what happened to the answer? Did it go up or down? Down. By how much? No, that's what the x's went down. What did the answer go down by? Went from 12 to negative 10.
By negative 22.
So we subtracted 22 from our answer. Okay? Everyone good with that? Adriana, does that make sense? Yeah. Good? Okay. What do I do next, people? Yeah, let's divide by negative 19, both sides. And I get, that means 1x will have to equal, or two negatives make a positive, so we can just say 22 divided by 19. Okay, now, that number is perfectly reasonable, but because it's quite a nasty decimal value fraction, I am going to look myself, and whether you can see, have we made any mistakes anywhere? So, because I've got it all labelled, that's really easy to do. All right, so let's have a look. Did I multiply number 1 correctly? So 5x, I'm just checking I've written it correctly, and I have. Number 2, I've written out from the book. I have written that correctly. Okay. Did I multiply all this correctly? So multiply by negative 2 gives me... Is that all correct? 5 times, that's correct. Negative 3 multiplied by negative 2 is positive 6. 5, negative 10. Okay, that's good. 3 lots of 3 is 9. 2 lots of 3 is 6. 4 lots of... All right, so I've got that right. Let's just check that the difference, therefore, there's no difference in the y, so I don't need that. 9 to negative 10 is negative 19. 12 to negative 10 is negative 22. So that's all good. I'm actually happy. Now, we might find that there's a problem with that one in the book. They might have written it, but are we happy with everything we've done? We can't spot a problem, no? No. So let's assume in there that that is fine as it is. What we didn't do in the previous one is find the y value. Now let's do this because it's going to be a tricky one because of the fraction. So I'm going to use that. I'm going to use x equals 22 over 19 in I'm going to use equation number 2 just because I like the look of it. Okay, I could use these, I could use these. It's completely up to whatever you want to do. All right, but let's do it. So we've then got, using number 2, I've got 3 lots of x. So that's 3 lots of 22 over 19 plus 2y's is equal to 4. Are you happy with what I've done there, everyone? Yeah. So it's difficult numbers, but it doesn't change the maths. And sometimes I think some of you think, oh, because the numbers are more difficult, the maths changes, but it doesn't. So what is 3 lots of 22 19ths? 66 19ths. How do I, well, let's just do plus 2y is equal to 4. What do I do now?
Negative minus 66 19.
Yeah, let's subtract that, okay, over here. So 66 19. So we've got to be able to do now, guys, 4 subtract a fraction. How do you subtract fractions? What's the first thing you have to do? Common denominators is better, isn't it? So we've got 2y's and 4 needs to be something divided by 19. Anyone tell me what that is? So we need to do 4 multiplied by 19. So that 76. So 76 divided by 19 is 4. So then we subtract 66 over 19. So we get 2y's is equal to 10 19ths. Yeah? Everyone good? Jack is? Yeah, okay. Well, if 2y's are 10 19ths, what must 1y be? 5 19ths. Okay. So I can put that as my other solution. So, same principles, guys, but the fraction did make it harder. Now, I'm thinking if we looked in the answers for the book, it might not be that as an answer because that's a messy one to have. But it works, and working with fractions. But it wouldn't work with decimals, guys. You'd be rounding. It would. There's no way it would work with decimals. So we have to be able to work with our fractions. But let's just go back up to where we started, which is the important bit, which is you first off have to make one of your variables, either the x or the y, the same amount so that it's not impacting the change in the answer, okay? Then you figure out how much the variable that changed the answer has changed the answer, okay? Then you use that answer to work out the other variable. So if we go back to the one that had no fractions, we can probably see it now and say, right, we did the 6x's. The reason why we picked the x's first, I picked that one because I knew the positive and negative might have a problem. All right, well, it's going to switch off in a second. So let me know if you have any issues, and we'll be working on that for tomorrow. Okay? Good stuff. The video will be posted in a sec. All right.